Hey there, ready to dive into the world of partial derivatives? Get ready for some mind-bending fun as we unravel the mysteries of these mathematical beasts together. So ladies and gentlemen, here we're given h as a function of s and t, right? And then we are asked to partially derive it, right? Perfect. So we're going to do this. I'm going to firstly rewrite every term in form of a multiplied by x to the power n, because this form is making sure that we are at ease to can differentiate, right? Perfect. So let's do that. So I'm going to rewrite this as h s t is equals to, okay, the first one is sorted, so it's t to the power 7. Then we have ln s squared, that one is sorted. And then here, this 3 must go up, right? So the 3 must go up. So we're going to have plus 9. Okay, actually, let me do this, guys. Let me do this. I'm going to erase this here. Let's just make it smaller there so that we can have space, right? So we're going to say here plus 9t to the power negative 3, because the t to the power 3 becomes a numerator now. The sign of the exponent must change. And then we have minus s. Remember I said this is the numerator, that is the denominator of the exponent. Ne? So you have 7 through, it means you're going to divide the inside exponent by 7. That's what it means. So it's 4 over 7. Now everything is written in form of a times x to the power of n. So we can easily differentiate now. So I'm going to find the partial derivative of h with respect to s. Ne? Sharp. So it's like s is our variable now. Any other letter is a constant. Okay? So we already know that this part here is going to be 0. Why? It doesn't have s. So basically I'm just differentiating this one and that one, because this has an s there and also there. Alright. So t squared is like a coefficient in this case. It's like a number. So I'm just going to leave it as t squared. Now I need to differentiate ln s squared because it has the variable of differentiation. Remember, the derivative of a ln function is basically s squared. You take the inside. The inside is always your denominator, and then you derive it. So the derivative of s squared is 2s. So that becomes your numerator. No? Perfect. I'm sure you saw that. So the derivative of the inside is your numerator, and then the inside still stays the same at the bottom. That is the derivative of a ln function. Perfect. And then now we're going to derive the last part. Remember here there's an invisible one. This one becomes 0, so we don't care about it because we're deriving with respect to s. So here we have 1. So it's going to be minus 1 times 4 over 7. It will be minus 4 over 7. Then we're going to have s, right? And then now we're going to have this guy. Oh, sorry, let me use the thing. We're going to have this guy minus 1. So 4 over 7 minus 1 is negative 3 over 7. So that gives us negative 3 over 7. And then we have differentiated with respect to s. We just need to simplify things wherever we can simplify, right? So let's simplify and see. So I'm going to have, okay, I'm going to have 2 over s, because one of the s will cancel there, so we're left with 1 s at the bottom. And then we have t squared here, minus 4 over 7 s to the minus 3 over 7. You can leave your exponents as negative or you can leave them as positive. It's entirely your choice. Ne? But we're going to mark it correct either way. Right. So now let's do the derivative with the partial derivative with respect to t. Okay, so all this will be gone now. all this will be gone now. So we're going to do with respect to t now. Okay, so with respect to t, let's see, let's go back there. So obviously we know that the last part will be 0. Why? Because it doesn't have t, doesn't have a variable of differentiation. So now I'm going to differentiate this guy and that guy, right? So here I have 1 times 2, which is 2. And then it's going to be t to the power 1. Remember, when you differentiate the exponent, it's always 1 less. Then ln s squared x acts as a constant. And then we have positive 9 times negative 3, that is negative 27. T, it's always 1 short, so we minus 1. So minus 3 minus 1, it's minus 4. And the last part, as I said, we're not going to differentiate. It becomes 0 because it doesn't have what? It doesn't have the variable of differentiation. And there you have it, ladies and gentlemen. We have conquered the world of partial derivatives together. Keep flexing those maths muscles and stay curious. Thanks for joining me on this world ride. Until next time, keep calculating, keep smiling.